The first chapter that we will be doing today will be on kinetic particle theory. This is one of the most fundamental chapters that you must know. The concepts are very simple and very straightforward. Basically, this chapter is to divide it into, for you to know what is the state of matter. The state of matter exists as solid, liquid, gas. So what are some of the things that you need to know? You need to know the arrangement, how are they arranged, and you must be able to draw the particles when they're in boxes. So for example, this is how you draw solid, and this is how you draw liquid, and that is how you draw gas particles. And do take in mind that in exam, if they ever ask you to draw solid particles arranged in these boxes as also compared to liquid, you must make sure that the number of particles here must match the number of particles here. This is a very good practice. And also the next thing that you need to know is the movement, how to actually describe the movement of the particles in different state. For example, in solid state, we will know that they are packed very closely together. So remember the keyword, pack closely together. As a result, you have a strong attraction force, and as a result of this strong attraction force, it can only vibrate at its fixed position. So these are some of the keywords that you need to see in your answers. So for liquid wise, instead of packed closely, they are packed relatively closed. However, it's not as close as while in solid, and they still have a strong attraction, but it's weaker than in solid. So you're actually making a comparison, and they will vibrate and moved throughout the liquid structure. So instead of staying at a fixed position, you will vibrate and move throughout the liquid structure. However, for gas, it's more free because the particles are further apart and the attraction force between them are weak, and as a result they can move freely throughout the entire structure. Okay, so with all this information, we must come to conclusion of some properties of particles in solid, liquid, gas. For in solid, we know that due to its orderly arrangement, it must have a fixed shape, and it must have a fixed volume, but it cannot be compressed. So in liquid wise, you know that due to its arrangement, it has no fixed shape because you can see that the structure looks rather distorted. It has a fixed volume because the amount of volumes remains the same, and it cannot be compressed just like the one in solid. However, for gas, there is no fixed volume, no fixed shape, and it can be compressed because there's a lot of gaps in between here that you can actually compress it. So next, I will move on and talk about how you actually describe them in individual physical process. What does physical process mean? Physical process means such as melting, boiling, freezing, and condensation. So these are what I mean by physical process. And also addition process such as sublimation, evaporation. So I will explain individually how you actually describe them in words, but before that you must know how to actually draw the graph, the temperature time graph for all this process. So this is degrees, this is time. So let's say for example I'm drawing something like this. This period is whereby it will undergo the process of melting, whereby at here it will be in solid. Let's take water for example. It will be solid, which is ice, and at this stage it will be ice plus water, and This process that is happening here right now is called melting. That means ice is being melted into water, and this stage it will be water, and at this stage it will be boiling. This is the boiling stage whereby it will be gas plus water. So how do we individually describe what happens to the particles in each state? So let's look at melting. There's a few standard words that you must know how to describe, and once you get a hang of it, all the subsequent questions you will be able to answer. So it's very straightforward. For melting, all you need to say is that it gains heat energy being converted into kinetic, causing the particles to vibrate so fast until it overcomes the strong attraction force between the molecules, but between the particles, sorry. And for boiling, you can actually repeat the same thing that is written here. However, you have to change a few words. You must say that the liquid particles gain enough energy, causing it to vibrate even faster to overcome the relatively strong attraction force between the liquid particles, hence causing it to break free to become gas. And for the reverse process of freezing and condensation, is easier to phrase. So if here is where you gain energy, and for freezing and condensation, we will say that the particles lose energy. It loses energy, as a result causing it to slow down in its vibration or motion, hence coming together to form either solid, which is for the process of freezing, whereby it's ice, water to ice, or liquid for the process of condensation. And there's two more special process that you must know, which is sublimation. Sublimation is the change of state between it changes from solid directly into gas. This is known as sublimation. What you need to know about this sublimation is that you must know that it changes from solid into gas, and you must be able to name a few examples. And some of the examples that you have to memorize is NH4Cl, this is ammonium chloride, or dry ice, which is CO2. This dry ice is what you can find in a fire extinguisher. And mothball, which your parents will put in the closet. All these are some of the examples you need to know. And the opposite, the reverse process of sublimation, is actually known as condensation. This is something that a lot of people do not know. So if I want to change gas back into solid, the name is called condensation, which is similar to changing gas back into liquid, also called condensation. So let's talk about the very last process, which is evaporation and how it works. Evaporation works by the more active or the more energetic particles will escape the surface, leaving behind those particles that are weaker and has less energy. And as a result of that, the temperature drops. That's why when you have fever, your parents will put a wet towel on your forehead. This is to actually cause evaporation to occur, hence making those more energetic particles, which is the heat source that causing you to have fever, to escape off, as a result to lower your body temperature. So this is one of the everyday life application of evaporation. So with that, we have come to the end of the first chapter, which is basically kinetic particle theory. However, there's one last part that I need to go through. The last part for this chapter is actually diffusion. Diffusion is something that you might learn in bio, but however it's also needed in chemistry. So for example, if I have this, okay, no, a very common O-level question will look something like this. This is like a piece of paper, and this is two test tube inverted, and this is filled with different gases. So as I remove this, diffusion will occur, particles will start to travel. So how it travels is that it will diffuse from a higher concentration to a lower concentration, and as a result, at the end of the day, you will see a very even mixture of both inside this container, but it must after quite some time. So what affects the rate of diffusion? That means, how do I know whether this diffuse faster or this diffuse faster? The rate of diffusion is determined by two factors: temperature. Let's talk about temperature first. That means if I have this gas, I have gas A and gas B. If I decided to heat gas B and this gas A I don't heat, and both of the gas are exactly the same, you'll realize that this one will diffuse over faster. That means the gas from here will reach this point before this gas reaches this point. So that's the first concept. The second concept is the MR, relative molecular mass of the gas. So for example, if I have H2 versus O2, so here is H2, here is O2, which one will diffuse faster? The answer is H2, because H2 has a relative molecular mass of 2, and this will have 32 if you look at our periodic table, 16 plus 16. So a person that is lighter versus a person that is fatter, and they are both running in opposite direction, which one will reach the opposite point, opposite end first? Of course, the one that is lighter. So H2 will diffuse here before OH able to diffuse through. So this is the last concept that you need to know for kinetic particle theory.